So in section 9.4, it's not really much new here. It's just that now we're applying our knowledge to three-dimensional figures. So I'll let you kind of mess with this top problem a little bit. You should try to do it first on your own. You can pause this. What you realize, though, is in a rectangular box, the longest dimension would be like from the top back corner, for example, you know, so this would be, I'll call this D, whoops. That would be the space diagonal. So what you have to do is you have to do Pythagorean theorem 2 times, right? So the box is 9 units high and it's like 20 inches deep, 25 across. So this X here going across the bottom, you can find that by doing Pythagorean theorem, right? Because you could do 20 squared plus 25 squared equals X squared. Once you find X squared, you can then do Pythagorean theorem again for this invisible right triangle that's standing up inside the box. 9 squared plus X squared equals D squared. And solve it that way. You should end up with yes, this thing does. The 33-inch golf club would just fit in there. Okay. You can take a look at my posted solutions as well. I'm going to spend a little bit more time with this. Let's do this in general terms, okay? So check this out. This is kind of cool. We're going to derive something new here. So if I call this D and I call this X, and let's say this is A, and let's say that this is B and this is C. Well, to find X squared, that's the diagonal of the bottom of the box. We would say that X squared has to equal B squared plus C squared, right? Just Pythagorean theorem. Now, once we have that, we can then use the invisible triangle standing up in the middle of the box to do this. Remember, the diagonal of the box is D. It's like the space diagonal. And then now with some algebraic substitution, we know that B squared plus C squared is the same thing as X squared. So now A squared plus B squared plus C squared equals D squared. I call this like super Pythagorean theorem. So, and this is true for any, prism, like a box type thing with length, width, and height. To find the space diagonal, you do the length squared, the width squared, the height squared, add those all together, take the square root. There you go. So it's really the same idea of, stuff we've done before. Now remember, when it says to find the diagonal of a solid, that means the space diagonal. And it says with dimensions of 4 root 2, 4, and 2 root 10. So, I could draw in those invisible triangle, so we have to find this. But now that we've derived this formula, I don't need to do it in 2 parts. I can just say 4 squared plus 4 root 2 squared plus 2 root 10 squared equals D squared. So it's a little bit shorter this way. So this would be 32. This would be 40. So we get 88 equals D squared. And that, of course, would be 2 root 22. So again, we're still simplifying radicals. We're still using Pythagorean theorem. The only thing that's changed in this unit is the fact that we're doing, three-dimensional figures. Okay. I'll give you the answer here. You should get 60. I'll post my solution. So it's a little bit more in the solutions, but I'm not going to do that in the video. I think you'll be fine with this. Now, in the next page, here we got some pyramid action. So I am going to talk about this a little bit. There's some new terminology here. Okay. So first it talks about the slant height PR. Now this thing isn't quite drawn to scale. The slant height is perpendicular to the base edge and to its midpoint. So what I mean by that is, even though it doesn't look like it, AR is congruent to RD, because this slant height PR comes down and cuts the base edge in half, and then it's going to form a right angle here as well. Okay, so the slant height is from the peak of the pyramid down like the middle of the face of the pyramid. Okay. It says that the slant height measures 10. The base diagonals. Now, I need you to think about this a little bit. First of all, a pyramid, I should have mentioned this before, is named by the base. So when it says, this is a little bit redundant, really, regular square, I mean, a square is regular by definition, but that means that the base of the pyramid's square. Most pyramids are square pyramids. Okay. So if we have a base diagonal of 12 root 2, now the base diagonal isn't in this figure, but that means that the side would have to, a base diagonal would cut the square into two 45, 45, 90 triangles, right? So if that base diagonal is 12 root 2, the base edge would have to be 12. Okay, so this RD must be 6. So ID would have to be 12 because that's the base edge. Okay. The altitude PY, so that goes from the center, the top of the peak of the pyramid to the center of the base, even though, again, it doesn't look like it. It's going to be drawn perpendicular. All right. So if this ID is 12 and this PY is drawn right to the center of the square, RY would have to be 6 because it'd be half as this. Then look at this triangle that's standing up on the inside. If that hypotenuse is 10 and this leg is 6, clearly PY would have to be 8. Okay, because it's a 6, 8, 10 triangle. RD we already found earlier, that was 6. So PD, the lateral edge, so that goes from the peak of the pyramid down to the vertex, one of the vertices of the base. So PD, same thing as PA, PM, and PI. Now you got to be careful here now. So now there's a different right triangle. Very easy to make a mistake here. Watch this. You see, I'm now going to look at this right triangle here. This right triangle is on the face of the pyramid. And it's very easy to say, oh, that's 10, that's 6, and to say that this is 8, but that's not correct. Because remember, this 10 is is a leg. So that would be 10 squared plus 6 squared, 136. Square root 136 ends up being 2 root 34. And that is PD. Okay? So just be careful. There's multiple right triangles in these figures. You have to make sure you're using the right one. Now, on this one, first of all, I'll give you a little drawing lesson. If you have to draw a square pyramid, when you draw the base, you really want to draw like a rhombus. That way it creates a little bit of perspective. You get a little depth. Just kind of pick a point up here someplace. and then you connect all those, and you see it kind of comes together, right? Regular square pyramid, the perimeter of the base is 24, so each side is 6. I'm going to draw in a slant height. Slant height goes to the midpoint of the base, so of the base edge. So that has to be 3. It says the slant height is 5. Remember, this has to be 3 as well. And that forces the altitude to be 4. 3, 4, 5 triangle. Okay. These next two I'm going to leave for you. This answer here, the slant height is usually represented with a cursive L. I'm not really sure why, but you're asked to find the slant height. It ends up being 13 here. Okay, this next one's a little bit harder. So I need you to take your time and think. You have to find IA. IA is this segment from here down to there, of course. Now, I would think of this, I'll kind of help you get started. This one's a little bit harder. I would think about drawing an altitude to the middle there, to the middle center of the base. And I would think about creating this big right triangle standing up in the middle there, okay? So you're given that, it says it's a square prism. So if this is 6, you should be able to find A to the center there, okay? And you're going to have to think about this a little bit. IE is 3√3. You got to mess around with some triangles there to see if you can get that top part, all right? So, but I'm not going to cover this in the video. I want you to try this yourself. You can take a look at the stuff that I post on Canvas. That'll help you. The answer for this ends up being root 67. All right, but go ahead and give it a shot. And if the stuff that I post on Canvas doesn't make sense, then you want to come into office hours, okay?